Hey, what's up? I got notes 151. I want to talk about the inverse of a square matrix. So square matrices. So we're going to talk about matrices that are just 2 by 2s, 3 by 3s. I know, 4 by 4s. I know you're thinking we can go on and on and on. We're not going to do that. Uh, think about when you multiply. I've got 3 times 1/3. Anytime I multiply a number by its reciprocal, we also call that the multiplicative inverse, we get 1. So if we're going to go ahead and we're going to multiply matrices by the identity matrix, all right, we go ahead and we multiply. We get 1, 0, it's 1. We get, oops, gosh, my bars. 0, 2, 1, 3, 0, 0, 4. All right. So we call this matrix here, this one is called the identity. Okay, it's called the identity matrix. And it is, this would be I sub 2. Okay, so if I had a 3 by 3, this would be I sub 3. I could go on and show you lots of multiplication problems. And if we were in school, I probably would have given you a quiz question that had something like this on it where you're multiplying. So our rule is if we have matrix A times matrix B, and that is equal to the identity, and similarly, matrix B times matrix A is equal to the identity, then A and B are inverses. Okay, then they're inverses. Okay, our notation for that is A times the inverse of A is equal to the identity. Okay, A times the inverse of A is equal to the identity. The next thing I was going to do was go ahead and have you find the inverse. Can you see the paper here? Okay, so by hand, in old school, if I have a matrix here, matrix 1, 1, 1, 3, 5, 4, 3, 6, 5, what I'm going to do is I'm going to set it up and I'm going to put the matrix and the identity, and then I'm going to turn by hand, I'm going to turn this by using reduced row echelon form and find the matrix. So, if we're in school, I'm going to go through all these row operations with you. Notice I come up with a lot of fractions and I come up with my matrix. All right. In the interest of being in the 21st century and not having 40 minutes every day to do these problems with you, we are going to give it a shot with our handy dandies. Okay. So what you're going to do, all right, so what you guys are going to do with your calculators, hope you can see the calculator here. You're going to go ahead and you have this button here called matrix. So hit second and then matrix. Okay. You can see I already have a 2 by 2 stored in here. So I'm going to go to matrix A. I hit enter. Oops, clear. Sorry. Second matrix. I'm going over to edit. Sorry about that. All right. Now I need to tell my calculator that I'm going to use a 3 by 3. Okay. 3 by 3. And notice that all of a sudden my matrix comes right up. I'm going to go ahead and put those entries in 1, 1, 1. 3, 5, 4, 3, 6, 4. Okay, so I've entered the matrix here that I have for number 19 in our textbook straight up into our calculator, and I have it saved as matrix A. All right, so now I'm going to quit this mode for just a second, and I'm going to go back out. I'm going to say, hey, I want to go back to the matrix, the one I had 3, 3. Okay, I'm going to put that, hit the enter button. And I want to find the inverse. Well, notice the notation we used here for our inverse. We can use that right here on our calculator, and we can hit that inverse button. I hit enter, and I find the inverse of that matrix. Okay, so if this is matrix A, then by using my calculator, I figured out that A inverse is going to be equal to the matrix 4, -2, 1, 0, -1, 1. This is totally the wrong answer. What did I do wrong? Hold on. Doing this in one take, kids. Edit. 3 by 3. 1, 1, 1. 3, 5, 4. 3, 6. See how easy it is to make a mistake? Goodness gracious. Enter. Quit. Try that again. There we go. We got the right answer this time. All right. So that's the wrong answer. So we will say A inverse is equal to 1, 1, negative 1, negative 3, 2, negative 1, 3, negative 3, 2. Sorry about that. But, you know, just to show you how easy it is to make mistakes. Had I continued with this wrong matrix, I could, though, go ahead and check it on my calculator. So I could store this into my calculator. I don't know if you guys have know this yet, but I could go back to my matrix menu and call matrix B. I'm going to go over to edit and matrix B, and I say this is a 3 by 3 matrix. I'm going to go ahead and put it in. I'm going to put it in correctly this time. Negative 3, 2, negative 1, and 3, negative 3, 2. All right, so hopefully this is right. Hit the enter button. Quit. All right, so if I look at my matrix menu, I have 2 matrices stored. Suppose I want to multiply. I want to double check that I have the right. I want to double check that I did this right. I want to know, does A times the inverse of A, does it equal the identity matrix? Okay, so I have matrix A. I hit the times button. I go back to matrix B. Okay, and I hit enter. And look at that. That is beautiful, isn't it? Absolutely beautiful. That's the identity matrix, exactly what we wanted. Okay, so we can check that by using the calculator. I know what you're thinking. Yeah, like that's great, 3 by 3. But Glennon, there's got to be a shortcut. You always show us shortcuts. So let me show you a shortcut for a 2 by 2 matrix. Now this is only going to work for a 2 by 2 matrix. Now if I have the matrix, I'm just going to use a generic matrix A, B, C, D. All right, we'll call it A, B, C, D. So to find A inverse, what I'm going to do is I'm going to do crisscross. I'm going to multiply 1 over AD minus CB, okay? And then I'm going to take the switcheroo. It's actually called the adjoint. So, but what I'm going to do is I'm going to switch the spots of A and D. So D and A switch spots, and I switch the signs of C and B, okay? So, which I'm going to show you this right here in tomorrow's lesson. This is called the determinant. Okay, the determinant, it's right there, determinant, all right? And you know that there's no way it can't equal 0, right? Can't equal 0. Why can't it equal 0? Because it's in the denominator of a fraction, right? Cannot. So what happens if it does equal 0? If my determinant is equal to 0, then that means that there's no inverse. I know, not every matrix has an inverse, all right? So if we take a look at number 35 from our textbook, we have the matrix A, really creative name, 2, 3, negative 1, 5, okay? So I want to know what is the inverse of this matrix. Well, I'm going to go ahead and follow the formula I just showed you up here. So A inverse is equal to 1 over, okay, 1 over. I'm going to crisscross multiply. So 2 times 5, which is 10. And then I'm going to do negative 1 times 3. So that's going to be minus a negative 3. All right, so that's going to be 1 over 13. All right, I'm going to move these 2 spots. A and D are going to switch spots, 5 and 2. All right, and then the signs on the other 2 are going to change. Okay, so what I'm going to end up doing here is scalar multiplication. All right, so I'm going to multiply each of these by 1/13. So it's going to be same size, a 2 by 2 matrix. Not sure if you can see it all the way down here at the bottom of the paper. Here we go. So it's going to be 5 over 13, negative 3 over 13, 1 over 13, and 2 over 13. All right, so we have found the inverse. Now, if you feel like checking, make sure I got it right. You could take matrix A and the inverse here, multiply them together. Remember, matrix A times the inverse is equal to the identity. All right.